Today we're going to look at vectors for another dimension. Today we're not teaching vectors, but we've done videos on tutorial on vectors and scalars. But today we are solving past examination questions on vectors. We're looking mainly on examination on UTME or University Entrance Examination past questions on vectors. So we're going to solve as many as possible. So stay connected as we look at these problems on the board and many more to come. If you are not subscribed to the channel, go straight now to the subscription icon, the small bell below the channel's name, Best Science Brain, and then tap on the subscription button once and get subscribed. So you can be seeing our videos on chemistry, physics, and further mathematics. So let's go straight to the questions. The first question says, if the angle between two vectors P and Q is 0 degree, the vectors are said to be option A, be perpendicular, option B, be parallel, option C, intersect at 60 degrees, option D, intersect at 45 degrees. So this is University Tertiary Matriculation Examination 2004. So looking at this problem is an entrance examination question to candidates looking for admission into the university or higher institutions. So to solve this problem, if you look at if you listen to if you have watched our previous tutorial on vectors, I say that when two vectors lie parallel to each other, the angle between them is 0. We have a vector, this is vector A, this is vector B. So these two vectors are said to be parallel to each other. And the angle, there will be no angle because angle is made when two lines intersect. So when two vectors are parallel to each other, the angle between them is 0, and such vectors will produce maximum resultant. So the answer to this question is option B. So when the angle between two vectors is 0, they are lying parallel to each other. But if the angle between the two of them is 90, we now say that the vectors are perpendicular to each other. So that is the answer to question number 1. So as you look at the solution to number 1, we now move to number 2 question. Number 2 says, the resultant of two forces, 12 Newton and 5 Newton is 13 Newton. What is the angle between the two forces? The resultant of two forces, 12 Newton and 5 Newton is 13 Newton. What is the angle between the two forces? Option A, 0 degree. Option B, 45 degree. Option C, 90 degree. Option D, 180 degree. This is University Entrance Exam 2008. So let us solve this problem. To solve this problem, we use the parallelogram law of vectors for finding resultant. That says resultant square, since the vector is a force, given as F1 squared plus F2 squared plus 2 times F1 times F2 cos theta of the angle. Now the resultant from the equation is 13 Newton. We now replace this with 13 squared equal to, we have the two vectors 12 Newton and 5 Newton. So we can take our F1 as 12 and take our F2 as 5. We now have 12 squared plus 5 squared plus, follow the formula, 2 times 12 times 5 cos theta. Theta is the angle between the which we are looking for. So 13 squared gives us 169. 12 squared is 144. 5 squared is 25. 144 plus 25 gives us the same 169 plus 2 times 12 is 24. 24 times 5 is 120 cos theta. We now take like terms. Crossing over, 169 minus 169 equal to 120 cos theta. That gives us 0 equal to 120 cos theta. Making cos theta the subject. Cos theta now becomes 0 over 120, that will still give you 0. So theta now becomes cos inverse of 0. And then the cos inverse of 0 gives us 90 degrees. So the vectors are mutually perpendicular. The answer to this question is option C, 90 degrees. So as you look at the tutorial, we prepare for the third question. So we'll go to the third question here, over there, on the other side of the board, that says a body of mass 4 kg resting on a smooth horizontal plane is simultaneously acted upon by two perpendicular forces, 6 Newton and 8 Newton. Calculate the acceleration of the motion. So a body of mass 4 kg resting on a smooth horizontal plane is simultaneously acted upon by two forces that are perpendicular, 6 Newton and 8 Newton. Find the acceleration of the motion. We have option A, 2.5 meter per second square, option B, 3.0 meter per second square, option C, 4.0, option D, 4.5. This is a inverse UTM equation 2008. Now, for us to solve this problem, let's assume that this is the object or the body. Two forces are acting on it, and those two forces are mutually perpendicular, acting at 90 degrees. And the mass of the body from the equation, the mass of the body is 4 kg. Okay? Then the two forces acting on the body are force of 6 Newton and 8 Newton. So let's assume that 6 Newton acts upwards and northwards. And let's assume that 8 Newton acts eastwards. So these forces are mutually perpendicular. The angle between them is 90 degrees. Now we know implicitly that force is mass times acceleration. So acceleration is nothing but force over mass. So we're not going to use 6 Newton to solve this problem, neither are we going to use 8 Newton, because if we use 6 Newton and 8 Newton to find acceleration, we get different answers. So what we're going to do is, we're going to find the resultant force, the force that replaces these two and have the same effect. So since they are mutually perpendicular, we'll find the resultant by applying the Pythagoras theorem. You can visit our videos on vectors and then look at the tutorial. Listen to the tutorial. So here is 6, this place is also 6 Newton. So this place is a resultant, they call it FR. The angle here is 90 degrees. So they call here A, B, C, D. They look at triangle CAD. So they look for the resultant, that is the hypotenuse for the triangle resultant. So now FR squared equal to the angle here between the opposite squared, C squared, plus adjacent square, which is A squared. So FR squared becomes C squared 36, A squared 64. 36 plus 64 gives us 100. So FR becomes square root of 100. That will give us 10 Newton. So our FR is 10 Newton, which is the resultant force. We go to the formula, acceleration, which is force over mass. We now use the resultant force in place of F, which is 10 as our force over mass. Mass of the body is 4 kg. Divided by force is already in SI unit. And that will give us 2.5 meter per second squared as our answer. So the answer is option A to this problem. Which says, which of the following is a set of vectors? Option A, force, mass, and moment. Option B, acceleration, velocity, and moment. Option C, mass, weight, and density. Option D, mass, volume, and density. University matriculation, tertiary examination, University examination 1989. So that should be UTME, University Tertiary Examination, like Jamb exam 1989. Now looking at this problem, we have to screen the options. The right answer to this question is option B. Option B include only vectors. So why is A not the answer? In A, force is vector, moment is vector, but mass is not vector. As I pointed out in the early video, I said that fundamental or base quantities are scalars. So mass is fundamental and mass is scalar. Option C, mass also is a fundamental quantity, scalar, and also density there, even though it's derived, is also a scalar quantity. So mass and density are scalars, even though weight is vector. So C is not the answer. Look at option D. Mass, volume, and density, three of them are scalars. So the answer number 4 is B. We now go to number 5. Number 5 says the magnitude of the resultant of two mutually perpendicular forces F1 and F2 is 13 Newton. If the magnitude of F1 is 5 Newton, what is the magnitude of F2? Option A, 2.6 Newton. Option B, 8.0 Newton. Option C, 12.0 Newton. Option D, 18.0 Newton. UTME exam 1989. So let's look at this question once more. We are told here that the forces are mutually perpendicular. That means they act at right angle to each other. So we're going to draw a rectangle to present the vectors. These sides are parallel and equal. These other sides are parallel and equal. So let's call this side F1, F1 also, F2, and then F2. So they are acting at 90 degrees. And when two vectors are acting at right angle or when they're perpendicular, the resultant is diagonal drawn from their point of intersection. So this line represents the resultant. So we'll go back to the equation. It says that the resultant of the two forces F1 and F2 is 13 Newton. So we'll clean up the resultant and write 13 Newton at this point. And we are told if the magnitude of F1 is 5 Newton, we'll go up again. F1 is 5 Newton. We're now asked to find the magnitude of F2. That is a very simple task. We look at it, let's call here A, B, C, D. Then look at this triangle, triangle C, A, D. Let the angle here be theta. Triangle C, A, D. This is the hypotenuse. This is the opposite, the side facing angle theta. This is the adjacent. Of course, this is the right angle triangle. So to solve for sides of a right angle triangle, when two sides are given and one side is unknown, we are applying Pythagoras theorem to solve this. So the hypotenuse square, which is 13 square, equal to opposite square, which is 5, plus adjacent, which is F2 squared. So now 139, now squared is 169, 5 squared 25, plus F2 squared. Collecting like terms, crossing over. Move over there. 169 minus 25, that's what we have here, equal to F2 squared over there. If you subtract, we have 144 equal to F2 squared. If you're looking for F2, F2 becomes square root of 144, and that will give us 12 Newton. So the unknown force, F2 12 Newton. If you go to the option C is the right answer to the problem. So you take a look at our solution as we go to number 6 question. So look at number 6 question now. It says two forces whose resultant is 100 Newton act at right angles to each other. If one of them makes an angle of 30 degrees resultant, determine its magnitude. This is UTME exam 1988. Two forces, I come again, whose resultant is 100 Newton, act at right angles to each other. If one of them makes an angle of 30 degrees with the resultant, determine its magnitude. So we will solve this problem by first of all drawing a rectangle, because the angles at the ends of rectangle should be 90 degrees each. So let's take this as one of the force, this one the other force. So this side and this other side are equivalent. This side and this other side are equivalent. Let's label the rectangle as rectangle A, B, C, and D. The resultant, let's call here Fy, call here Fs. Resultant is the diagonal drawn from the point of intersection of the two vectors. That the line, that resultant is this line. So that is our Fr. Let's go to the question again. Say, if the resultant, two forces whose resultant is 100, so the resultant given to us as 100 Newton. At 90 degrees, we know that. If one of them may start degree with the resultant, so we have to choose one. So we can choose Fs for convenience. So let Fs be the one that makes 30 degrees with the resultant. So put the angle here. If you want to choose Fy, then the angle will not be there, because the angle between Fy and this result will not be at this point, which should be at this point. But since we chose Fs, the angle between Fs and resultant is, we'll put it here. Since they say, take one of them. So whether you are using Fy or using Fs, you get the same answer. So we are now asked to find the magnitude of this Fs. So this is angle 90. Now look at this triangle here. Triangle CAD. This is a right angle triangle. This triangle, this side 100 is the hypotenuse, the longest side. While Fs, the side close to the angle, is the adjacent. We are now going to combine trig ratio, that is SOHCAHTOA, to solve this problem. To combine trig ratio, which trig ratio combines adjacent and hypotenuse, is cosine. So now I say cos of angle 30 equals the adjacent, which is Fs, all over 100, which is the hypotenuse. We make Fs, so Fs becomes 100 times cos 30, and cos 30 is 0.8660. That gives us 86.6 Newton as the magnitude of the force. So the answer to the question number 6 is option D. So take a look at our solution before we go to question number 7. We'll now to question number 7. Number 7 says two forces, each of magnitude 10 Newton, act on the body, one towards the north and the other towards the east. The magnitude and direction resultant is option A, 10√2 Newton, north 45 degree east. Option B, 10√2 Newton, north 45 degree west. Option C, 20 Newton, north 45 degree west. Option D, 20 Newton, north 45 degree east. Let's go to the question again and read it out again for better understanding. Two forces, each of magnitude 10 Newton. Two forces, each of magnitude 10 Newton, act on the body. One towards the north and the other towards the east. The magnitude and direction resultant is, and this question is UTME exam 2002. So let's go to the solution. From our understanding or our comprehension of the question, we know that the two forces have equal magnitude, that is F1 and F2 are equal at 10 Newton, and they act at 90 degrees. Why do we know that they act? How do we know that they act at 90 degrees? Because one is adding due north, like adding due east. So we can get the cardinal point. This is the north, this is the east direction. So one add due north, 10 Newton, and the one that add due east is also the same 10 Newton. They are equal to each other. That means we are drawing a kind of square. A square has four sides equal 10, 10, all round. Then we'll look at the resultant first. The resultant, since they are perpendicular to each other, the resultant is the diagonal drawn. Let's call here square A, B, C, D. This angle 90 also. So let's consider this triangle here. This is the resultant. Let's call it FR. The resultant will apply, since the Pythagoras theorem, we have FR squared equal to 10 squared plus 10 squared. Then the angle here, the theta, opposite squared plus adjacent squared. So FR squared becomes 100 plus 100 equals 200. If you look at the options, the answers are provided in root form, in short form, irrational numbers. So we have to put it in short form. So FR becomes square root of 200, which is something as square root of 100 times 2, breaking it. Out of these two numbers, 100 is perfect square. So square root of 100 is 10, bring out 10, then root 2. So the resultant is 10 root 2 Newton. If you go to the options for the answers, we have two answers that are contradicting each other. Option A and option B. 10 root 2 Newton, 10 root 2 Newton, each of them bearing 45 degrees. But the difference is the bearing. One is northeast, and the one is northwest. So go back to our diagram again to find the direction of the resultant, since it's a vector. Then find the angle here, theta. To find this angle here, we apply trig ratio, that is the SOHCAHTOA. SOHCAHTOA, the trig ratio we can apply here, that will be easy for us. This is the opposite, and this is the adjacent, that is tan. So now I say tan theta equal to opposite, that is 10, over adjacent, 10 over 10. That gives us 1. Tan theta is 1. So theta now becomes tan inverse of 1. Which angle has its tan as 1? Theta is 45 degrees. The acute angle that has 45 degrees has 1 as its tan value. So it's 45. And then the direction, look at A and B option, they are all carrying 45, 45 each. So we still have an issue to resolve here. We now look for the direction of the here is 45 degrees, so we're getting theta as 45 degrees here. But this is north, this is the north direction of the vector, this is the east direction. So now what do? How do we express the angle? The angle normally is expressed in terms of northeast or north. So the angle should be between north and east. We will look for the angle that is here. That is the angle here will be the angle that we can now express as northeast. Now to find the angle here, the sum of these two angles will be 90 degrees. So alpha becomes 90 minus 45, which is also 45 degrees. So that angle will be in north, the result will be in northeast direction. So the answer to the question is option A, 2 root 2 Newton, north 45 degrees east. So you take a look at the problem as we prepare for the next question. Wow, the question says find the resultant of the four forces. So we have four forces: 3 root 3 Newton, 10 Newton, 3 Newton, there's no force there, and then 6 Newton. So these are four forces inclined at different angles at a point. And they will have the options 10 root 3 Newton, B 10 Newton, C 5 root 3 Newton, D 5 Newton, and then this is a UME or UTME equation 2007. So how do we solve this problem? Go over to the other part of the board. To solve this problem, if you have viewed our tutorial video on resultant, you understand how it's been done, but I'll still go through it once more. To solve this problem, we need to draw a table. Serial number, we need there are four forces, 1, 2, 3, and 4. Then the forces given to us, they are all in Newton. The first move, let's move clockwise. The first force here is 3 root 3 Newton. Second force is 10 Newton. Third force is 3 Newton. And then going down, the fourth force is 6 Newton. The next thing we do is we find the angle, theta. What does theta represent when we did our video? Theta is the angle between each force and the horizontal. The angle between each force, or the line of the force makes with the horizontal. Now for 3 root 3 Newton, the one pointing vertically upwards, from here to the horizontal, or like this, is 90, the horizontal line, or this one, 90 degrees. Because when the vertical line meets the horizontal line, the angle made is 90 degrees. So these are 3 root 3 Newton and then the horizontal line. So our theta is 90 degrees for this. Then for the 10 Newton force, the angle, the force made with the horizontal is 30 degrees. Had it been the angle is here, had it been that the angle was placed at this point, 30, the angle theta cannot be 30, but the angle I consider is the angle the force made the horizontal line. So had it been that here is 30, then the angle would have been 60 degrees. That is 90 minus 30 giving us 60. But we are lucky that the angle is given to us straight away at the horizontal point. So that is 30 for 10 Newton force. Then for the 3 Newton force, the 3 Newton force is lying on the horizontal. It makes no angle, it's not inclined. So is 0 degrees. So no angle. Then we move, there's no force here. We'll now move to the 6 Newton force. The angle the 6 Newton force made with the horizontal line is 60. And as I said, let me repeat what I did again. If the 60 we have to be here, the angle wouldn't have been 60, the angle would have been 30. But the fact they gave us the 60 between the fourth and the horizontal line, the angle the 6 Newton made is 60 degrees. We write 60 here. Having done that, we'll find the horizontal component of the forces, which is F cos theta. We'll find also the vertical component, which is our Fy, which is Fy F sine theta. We resolve horizontally, we resolve vertically. So this will give us 3 root 3 cos 90 this side, 3 root 3 sine 90 on the other side, 10 cos 30, that is the force, cos 30 on this side, 10 sine 30 on the other side. Then 3 cos 0 on this other column, and then 3 sine 0 on the other column. 6 cos 60. 6 cos 60 on this column, and this column 6 sine 60 on this column. So not to be in a hurry to solve this, no, we are not yet through before you start calculating. Now to find Fs, you visit our tutorial and go through this once more. To find our the values of Fs or the horizontal component, what do? We look at the Cartesian plane, they draw it, that is this plane for the forces. We look at the plane to find our Fs or the horizontal component. We look at the vertical plane, which is the vertical axis. From the vertical axis, take the two ends as positive, and then cut to the right hand side, of the plane. So every force that exists on the right hand side of the plane, from the middle, right, it will be taken as positive. So while all forces that exist on the left hand side will be taken as negative. So let's go to the vector diagram again. 3 root 3 is at the middle point is taken as positive when you are finding Fs. 10 Newton is on the right hand side of the plane, positive. 3 Newton is on the right hand side of the plane, which is positive. 6 Newton is on the left hand side of the plane. So we'll now put negative here. I will repeat myself. To find Fs, we'll have to look at the plane very well. We'll cut from the vertical axis, positive at the top and bottom. They will move to the right hand side. All the forces on the right hand side will be taken as positive, while all the forces on the left hand side will be taken as negative. So you can see that 3 root 2 is at the middle, 10 Newton right hand side, 3 Newton right hand side will give them positive values. While 6 Newton to the left hand side is giving negative value. Then to resolve vertically to find Fy, we still go to the plane again. But this time around, we will not cut from the vertical axis, we will cut from the horizontal line and move upwards. Upper plane, all the forces on the upper plane will be taken from the middle, will be taken as positive, while all the forces on the lower plane will be taken as negative. Okay, let's go. Now, let's look at the diagram. 3 root 2, 3, 10 and 3 are on the upper plane. 3 root 3, 10 and 3 are upper plane. So we consider as positive is 3 root 3, 10 and 3. While 6 Newton is a lower plane, we taken as negative. We'll now write here as negative. So we'll go ahead and find 3 root 3 cos 90. 3 root 3 cos 90 equals 0 because cos 90 is 0. Then we'll find 10 cos 30. 10 cos 30 equals 8.66. Cos 30 is 0.866. 3 cos 0. Cos 0 is 1. So that will give us 3 times 1. Then minus 6 cos 60. Cos 60 is 0.5. That gives us minus 3. We sum up. When we sum this add up, we'll have 3 minus 3 cancel off, remaining 8.66 Newton as the net horizontal component. We'll now come to this side. Then 3 root 3 sine 90. Sine 90 is 1. So 3 root 3 sine 90 will give us 5.2 approximately. 10 sine 30 will give us 5. 3 sine 0. Sine 0 is 0. Will give us 0. Then minus 6 sine 60. Minus 6 sine 60 give us 5 minus 5.2 because sine 60 is 0.8662. So summing up to find our f of y, we now have 5.2 minus 5.2, they will strike off, give us 0, then 5 plus 0 give us 5 Newton. So having done that, we now draw our plane here. This is our positive y-axis, Fy, negative y-axis, positive s-axis, negative s for s-axis. Then our force is 8.66. So write 8.66 here, where our Fy is 5 Newton. It's positive value, we'll have it there. This is also positive, we'll write it here. If Fs were to be negative, we are writing it on this side. If Fy were to be negative, we are writing it on this side. So we are going to deal with this one as is only. We enclose it into a rectangle and then find our resultant. Here is 5. Here is also 5. 8.6, 8.6. So we'll draw a diagonal. Then diagonal becomes a resultant, or Fr. So taking Pythagoras theorem, we have R squared. R squared becomes 5 squared plus 8.66 squared. So R square becomes, to solve this out, this is going to be our 75.6, 25, approximately 100. So R becomes square root of 100, and that will give us 10 Newton. So the answer to the equation is, this is, that was the first option. Option A is, okay, 10 root 3 on Newton there. So the answer to the equation is option B, which is 10 Newton. Board that says find the horizontal net force. I will have a system of 4 forces, 8 Newton, 10 Newton, 6 Newton, 4 Newton. And the angles are given towards there, 60 degree and 60 degree over also under it. We have option A, 7 root 3 Newton, B, 17 Newton, C, root 3 Newton, D, 13 Newton, and the University Unified Tertiary Migration Examination 2004. So University Entrance Examination in Nigeria. So looking at this problem here, how do you solve this problem? We're going to find that we're looking for the resultant force of this diagram. So we'll go over to this side. Before we go over to it, we're going to make some modification on the diagram. We'll see that in this diagram, there's a horizontal plane or axis, but there's no vertical axis drawn there. So we're going to create an imaginary vertical axis with dotted line. We create an imaginary vertical axis. Okay. Having done that, we can now continue our solution. So down there, I'll draw a table, serial number, the forces, there are 4 of them, 1, 2, 3, and 4. Then the forces, the forces, moving maybe clockwise, this is 8, the first is 8 Newton, second is 10 Newton, can move the Newton, since it's already there, 6 Newton again, and then 4 Newton. 8, 10, 6, and 4. Then the next, we'll find the angle each of the forces make with the horizontal. The angle the 8 Newton made with the horizontal axis is 60 degrees. The angle the 10 Newton force made with the horizontal is 0 because it's parallel to the horizontal. So it makes no angle here. So the angle the 6 Newton made to the horizontal is 60. They are moving like this. So 60 degrees. The angle the 4 Newton made to the horizontal is 0 because it's parallel to the horizontal is 0. So having done that, we'll draw a line again and then find the horizontal component, which is Fs or f of s, which is f cos theta. We also find the vertical component, which is f of y given by f sine theta. We now move. This is 8 cos 60. This one going to be 10 cos 0. This side 8 sine 60, 10 sine 0. 6 cos 60, then 6 sine 60. 4 cos 0, 4 sine 0. Now, before we go ahead with the calculation, we have to give convention to the forces, plus or minus sign as we did before. And as I said, we want to resolve horizontally, define f of s. We move from the vertical axis or vertical plane. We'll give the two ends positive and cut all the forces on the right hand side of the plane are being positive. So 8 is positive, 10 positive, 6 positive. While the forces on the left hand side of the plane are giving negative. So 4 becomes negative force, minus here. Then we have to still look at f of y. So, and these signs or conventions to the forces when we are resolving practically, or f of y, particle forces. So, to do that, what we'll do is, as I discussed before, we'll move from the mid horizontal plane, the two ends as positive, we'll move up. From the middle up, all the forces are taken as positive. So 4 and 10 are positive forces. You have 10 and 4 taken as positive forces. 8 is also positive. Then the forces on the lower plane should be negative. So 6 is the only force that is negative here. So we'll now go and we'll solve this. We'll now find 8 cos 60. 8 cos 60 will give us 4 because cos 60 is 0.5. 10 cos 0. 10 cos 0 will give us 10 because 10 cos 0 will give us 10 because cos 0 is 1. Then 6 cos 60. 6 cos 60 will give us 3 because cos 60 is also 0.5. Then minus 4 cos 0. Minus 4 cos 0 give us minus 4 because cos 0 is 1. So having done that, we now do the other side. We solve the other side. We find f of y. For f of y, 8 sin 60. 8 sin 60 will give us 8 sin 60 will give us, let's get the value, done. Eight sin 60 will give us, sin 60 is 0.860, so let's use calculator and do this faster. 8 sin 60 will give us approximately 6.93. 6.93. Then 10 sin 0, sin 0 is 0, 10 times 0 gives us 0. Then minus 6 sin 60, minus 6 times 60 will give us approximately minus 5.2. And then 4 sin 0, sin 0 already is 0, so 4 sin 0 will give us 0. So we now add the values we have here. Now add on the f of s as is 4 plus 10 is 14. 14 plus, okay, we can get it clear without waste of time. 4 eliminates 4. 4 minus 4 is 0. Now we have 10 plus 3 giving us 13 Newton. The net force for the horizontal is 13. And then for this one, 6.93 plus 0, and then that will give us what? 6.93 plus 5 point minus 5.2. That gives us 6.93 minus 5.2 again. That gives us approximately 1.73 as our Fy, 1.73 Newton. So let's go back to the equation. What are we asked to find? We're asked to find, not even the result, we're asked to find the horizontal net force. The horizontal net force. We are done with the equation. The horizontal net force is nothing but F of S. The force acting on that is 13 Newton. We're not asked to find the resultant. So having we're asked to find the particle net force would have been 1.73 Newton. So we're not going to the resultant. So the answer to the question is 13 Newton with the horizontal net force. Option D is the answer to this question, 13 Newton. So you can take a look at our solution and then see how clear and perfect it is. We expect you to do your own or solve problems on vectors as much as possible. So we have come to the end of this YouTube tutorial on Best Science YouTube. Always subscribe to the channel. Share our YouTube videos on Facebook. Share it also on WhatsApp group of students in secondary schools, SS1, SS2, SS3, even those in SC that need this. So share it among yourselves. Learn it, study, for knowledge is power. So keep on watching. If you are not subscribed, this is your first time, or you are seeing the video for the first time, go to the channel, click on the link you're seeing, or go to Google or YouTube and type Best Science Brain, search, and then click on the subscription button or icon, the tiny bell that is under the Best Science Brain. As we get more subscribers, the time will come when we entertain live video or live teaching on chemistry, physics, and further maths. So thank you for listening and always stay connected.